All right. What's up, first period pre-calc? Well, I guess what's up every pre-calc class, because I'm hoping everybody's watching this video. It's funny because we post this for all our pre-calc classes, and then I go on like a week later and I check the views, and sometimes it's like 96 views. I'm like, yes, everybody watched it. Sometimes it's like 43 views, and I'm like, well, half of us are watching it. So I don't try to waste your time with these videos. I try to make them as relevant as possible. I'm hoping you enjoy these. If you do enjoy these, give me some feedback, because it's something I'm trying new this year. Every Monday night a video. So I have something set up here for you so that we can go rapid fire. I have 7 things that I'm teaching you, and I have 14 minutes to do it. That's 2 minutes a thing. We're getting after it. Every single one of these things is on the test this week, so you're welcome. It's just it's a review of a bunch of stuff you've done before. Hopefully you remember it. If not, pause the video, watch it twice. Let's learn it now, because better late than never. Okay? So we're going to look at 2 functions. I am going to use these 2 functions. I'm starring them right here. I'm going to use these 2 functions for every single thing we do in this video. Okay, so the first function is x squared plus 3x, and I labeled that f. The second function is just 5 minus x. I labeled that g. Okay, so this first function is quadratic. It's an x squared. We know it's going to kind of look like that. We're not sure exactly what. We know this one's linear with a negative slope, so it's going to look like that. Okay, just to get an idea of what we're dealing with. 2 simple functions. But the key is knowing what the heck all of these different symbols mean. Because as long as you know what it's asking, I have the firm and confident belief that you can do the math. So let's start. Number 1. F of 3 or G of 3. Those are 2 different things. This right here is your input, and you look at the name of the function. They want you to input a 3 into the f function. So that would be 3 squared plus 3 times 3, which would give me 9 plus 9. It would give me 18. So f of 3 equals 18. And if we did the same thing for the g function, g of 3, 5 minus 3 is 2. So g of 3 equals 2. No need to show the work on that one. So when you see, this is called evaluating a function. Just make sure you plug it into both of the inputs. If it has 2 x's or if it has 1, you're good to go. Okay, next one. What if they mix it up here? And they say, I want you to find f of x plus 2. X plus 2 becomes your input, and you plug that in to the x spots I'm highlighting here in your function. Or if you were finding g of x plus 2, you would plug x plus 2 into the x spot of the other function. Okay, let's just do the f function because it's more complicated. This one has a minus. I'll do them both. F of x plus 2. So I'd go over here, and instead of x squared, I would do x plus 2 squared. That's my new input. Plus, instead of 3 times x, it'd be 3 times x plus 2. Notice I took this original function up here, and I put a new input in, the one that they told me to. So then I have to FOIL this out. X plus 2 times x plus 2 is x squared plus 4x plus 4. I'm hoping you can FOIL that in your head now at this level. If not, work it out, keep practicing. And then we just distribute here 3x plus 6. So our final answer, there's only 1x squared. 4x and 3x makes 7, and 4 and 6 makes 10. It's not asking me to solve, it's just asking me to evaluate, so that's as far as I can go. Okay, don't need to factor it. And then for the other one, we would do, for the g of x function, we would do 5 minus, and instead of 5 minus x, it's 5 minus x plus 2, which once we distribute that negative through, our final answer would be negative x, and then 5 minus 2 plus 3. Okay, so those first 2 things there, are evaluating functions. Just look at what they want you to plug in and go from there. Okay, I'm going to erase this to give myself some new space. So if you need to pause to jot this down, please do. Otherwise, you can rewind because I'm about to erase to give myself some space. All right. On to, so check, check. On to number 3. I don't like those checks. Looks bad. Let's do that. 1, 2. 2 down, 4 to go. All right, now getting into some symbols that can be a little confusing, but not after we take care of it. The way I read this, that I'm circling right here, the way I read that is f of g of x. You're putting g of x in to the f function. Or could go the other way, g of f of x, where you put f of x into the g function. You say, huh? Here's all it is. Notice which one's on the inside. That becomes your input. So in this case, this right here, 5 minus x, is going to go there, and it's going to go there. It's going to become my input into the f function. So what do I get? I get 5 minus x squared plus 3 times 5 minus x. Technically, I just put the g function into the f. Now I have to FOIL this out again. 25 minus 10x plus x squared. Notice I just FOILed that in my head. You can do it. Take your time. First outer inner last. Plus 15 minus 3x. So final answer is x squared, negative 10x minus 3 more, and 25 plus 15 is there. So that is what I get when I do f of g of x. Pause there and look and read. Look at it if you need to, because I need to do the second one, g of f. G of f is going to get you a totally different answer, because this time you're putting the f function into the g. So the g function is 5 minus x. But if I put the f function in there, it takes the place of the x and goes in there. And that simplifies really quick to negative x squared minus 3x plus 5 once you put it all in the right order. Totally different and much easier, because it was asking you a different thing. So f of g, g of f, you got to be ready to do both. Moving on. That's called composition of functions. Composition of functions. What if you saw somebody ask you this? Find when f is equal to g. What do we do if we need to find when two things are equal? Guess what we do? We just set one of them equal to the other one, and we solve. Now here, if you forgot how to solve, that's a different story. I at least have to get you to this point where your setup is correct, but now you're on your own, okay? How do you solve an equation that has x's on both sides? You need to set it equal to 0, and then solve using whatever method you can. So I'm going to add this x, get it to cancel, which means I have to add it over here. And then I'm going to subtract this 5 to get it to cancel, which means I would subtract it over here. So after I've moved stuff, I've got this equation here. And I don't stop because, look, it is asking me to solve. It has an equal sign. When is f equal to g? So I set them equal, and now I'm solving. How do I solve this? I do not square root. I don't move anything over. I have to factor. Factors of 5 that give me 4. Boom. Negative. I need a positive 4. So positive, negative. Booyah. So my two answers are x plus 5 equals 0, which gives me negative 5. I'm showing all my work for the sake of the notes. And x minus 1 equals 0, which would give me 1. So my two answers are negative 5 and 1. Those are the two instances when the two functions are equal to one another. And you know, let me get you a veteran math teacher move, okay? I'm hoping that this makes sense. You set two things equal to each other and you get two answers. That's when they're the same. But let's get a visual action here. Notice that these two functions should be the same at negative 5 and at 1. So if we go to Desmos, I already have it typed in here. check it out. There's our two functions. I graphed them. You got the red quadratic and the blue line. Look at the 2 points where they're equal. -5. At -5, both of the functions go through 10. And what do you know? At 1, both of the functions go through 4. Those dots are the two dots that we just found algebraically. -5 and 1. What was it? -5, 10, and 1, 4. So like we just found the x-coordinates of those 2 points where the functions are equal. Now we're talking. I'm hoping something just clicked that's maybe never clicked before. All right, we got 4 minutes to go. Pause the video there if you want to see that again, but I have to erase. What if I ask you to find when a function, in this case I chose f, is equal to 0? Well, simple. You just write the function and set it equal to 0. And now you solve. You're like, wait, Smith, how do I solve that? There's not even a number or anything. It's just to remember, the key to solving a lot of equations is to factor. In this case, I factor out the GCF of x because now I can set both of those factors equal to 0, which is called the zero product property, and I get my two answers of 0 and -3. So in this case, the f function should go through the axis at 0 and -3. Let's go look at our visual. It's still up. There's the f function. Where does it go through the axis? Does it go through at 0, 0? Sure does. And at -3? Sure does. Okay, we found algebraically where this function is equal to 0. Nice. Okay, second to last one, making our way down, is they might ask you to find like f divided by g, and then they'll ask you about the domain. Okay, they'll ask you about the domain. So if you ever see this, you just set it up. X squared plus 3x, that's f of x. G of x was 5 minus x, I believe. So now I'm looking. What is the domain? Do we have any square roots that we have to deal with? No, so we don't have to do that. But we do need to deal with this because there is a value that x cannot be. What can x not be? We can do the math this way. We cannot let that equal to 0, which would mean x equal to 5. X cannot be 5 or else we will get undefined. Let's check it. 5 minus 5 is 0. Yeah. So x cannot be 5. So our domain then would be -infinity all the way up to 5, skip over 5, and then go to infinity. That is our answer. If I ever ask you something about domain, remember, you look for fractions and you look for square roots. Okay, because we can't have any negative numbers underneath the square roots. All right. And last but not least, this has been fun working our way through. This is a lot of stuff in one video. Watch it twice though, because my goodness, this is all on the test. Difference quotient, last question on the test. I'll go ahead and tell you, it's going to be the last one. So we already talked about what it is. It's a formula that you'll see again in calculus. It helps us find the slope. I'm just worried about the algebra. As long as you can pull it off, we're good. So I don't think I'm going to have time to solve this because I see my timer ticking. But as long as we set it up correctly, I have faith in your algebra. Okay? X squared plus 3x. That's the function. But to start, so we're going to have a big line. We're going to have h on the bottom. And in this first spot, before the minus sign, we're going to have f of x plus h. So I put x plus h as my inputs. Okay, and then that gets subtracted by just f of x. It's just subtracted by the normal function with just x's in. So there's my setup. Okay, there's my setup. I might have time. Let me just go until the video stops. X plus h squared. That's x squared plus 2xh plus h squared. You can do that in your head. You're getting better. Plus 3x plus 3h minus x squared minus 3x. And at this point, you just start looking for stuff to cancel. X squared, 3x, 3x. And from there, you'll stack it, factor out an x, and go. I'm running out of time, but hey, I hope this video helped. Don't forget to submit your questions and what you learned.